La xerrada i si hi ha presentació, jo voldria presentar la Núria Rueda, que està al nostre grup ja des de fa un temps, va començar amb nosaltres, és una estudiant, bueno, no sé si ja tens el títol, és enginyeria biomèdica ja?
Sí, ja sí.
Doncs va començar amb nosaltres fent les pràctiques al grup, després també al TFG, i bueno, i ara ja és enginyeria biomèdica i està amb nosaltres com a Haiku. Des del principi doncs, aportant molt d'ajuda tècnica i organitzativa i una gran excel·lència en el projecte de mesurar conductivitat a la suor de les persones. I ara, com veureu, doncs, aquesta és la feina feta dins del grup, liderat per la Laura i per l'Anna. I doncs, endavant, quan vulguis, Núria, jo crec que ja pots començar, no? Ja hi ha tota la gent.
Sí, comencem?
Són els 5 minuts de rigor, d'aquí, si vols, després de 35, i jo crec que ja podries començar. No sé, Isabela, com ho veus? Podem començar?
Sí, podeu començar. Com vulgueu.
So, hi everyone, I'm Núria Rueda, and I'm going to do a presentation about testing a conductivity battery sensor with real sweat samples that was done here in September in the CNM facilities. So first of all, I'm going to do a brief introduction about the T2 patch project. This is a single-use patch that uses minimum electronics and also uses a patented technology to measure sweat conductivity. This device uses a continuous sample collection and evaporation system that is able to monitor the status of the athlete. Also, this device has wireless communication capabilities. So the initial idea was to implement a radio frequency system that was able to connect with this kind of These races already have a radio frequency system. So if the patch also has this system, it would be able to communicate with the organizers of the race. So in 2019, the group was in contact with Emma Roca. So she decided to tell us that we should go to an ultramarathon to test the device with human volunteers and test the device with real sweat. So we went there. As you can see here, you can see Juan Pablo and Neus sticking and removing sweat patches from the volunteers' lower back area. And here we have a video where when the patch is full, they remove it from the lower back area. And in this case, in this test, the conductivity measurement was done using the impedance measurements. So this was done in situ, as you can see here with Laura and Anna. So they did there the measurement. So to keep with the research, we decided to use to change, and instead of keep using the impedance measurements, to use our conductivity battery sensor. So to do this, we had to compare our conductivity battery sensor with a commercial device. So the first step was to use calibration solutions in the laboratory with different concentrations of sodium chloride to test if the device was working right. So in this case, we validated that our conductivity battery sensor and the commercial conductivity sensor showed the same results as for the conductivities of these solutions. But we needed to also test this with real sweat, since the composition of real sweat is much more complex than sodium chloride. To do so, what we needed was volunteers to obtain real sweat samples. So this is when we decided to do a test here in the CNM facilities to obtain real sweat samples from volunteers from volunteers that are workers from here of the center. So the first step to do so was to get in touch with the ethics committee of the SIC to present a proposal so that they could approve it and the results could be published in the future. This is why the volunteers that participated here had to sign this informed consent to do the test. So, several steps were followed to do this test. The first one was the volunteers' arrival that due to the COVID crisis, they had to be separated into two groups of 6 people. So here we can see some of the volunteers. Then the second step was the data collection and documentation delivery that was coordinated by Laura Ortega, Ana Llorella, Celia Vicens, and also myself. Then we had to stick the sweat collecting patches in the lower back area of the volunteers. So as you can see here in all these pictures, we are just sticking the sweat collecting patches in the volunteers back area. And then the most critical part was the performing of the physical exercise by the volunteers. As we can see in these pictures, some of them decided to stay here in the CNM facilities and perform, follow a fitness video. And some of them decided to go run around the campus to sweat. In this video, we can see how much fun all of us were having. To obtain all the sweat necessary. And then after all the effort, when the patch was full of sweat, it was removed from the volunteer skin. And the sweat was stored in an Eppendorf with the help of a syringe. So when all of this was done and the test ended, we went back to the laboratory to measure the real sweat samples. To do so, we, as we said before, we compared the performance of our battery with the commercial device. As you can see here in the results, the results were really great because 74% showed a deviation shorter than 10%. And only 10% showed a deviation larger than 20%. So the results were really great, and this test really was helpful to validate our conductivity battery sensor. And before ending this presentation, we would like to obviously thank everyone who participated in this test, because this would not have been possible without you and your sweat. So thank you very much, everyone who participated.
Thank you, Núria, for the presentation. Now I think it's time for everybody to start making questions.
Núria, just a question. I was one of the volunteers, and I remember that before starting to exercise, we have to be weighted. So why was so? You need to know how much liquid we lose during the exercise, or?
Yeah, it was just to keep control of the water loss during the exercise. So since you were not drinking water, we want to keep the record of what was your weight at the beginning and at the end. Just to see how much water you lost during the exercise.
Just for the people to know, until you don't start to run, you don't sweat. Just by doing the the aerobic, I think we didn't get a large amounts of sweat.
No, people who decide to run sweat a little bit more, but everyone sweat very, very well.
There is a question from Cesar. Do you see the chat?
Yes, I was reading it. Yes, so yeah, this is the next step. We are actually doing it right now. And yeah, so what we want to do is to disintegrate the conductivity sensor in the sweat patch so that it absorbs directly sweat directly from the user's skin and does the measure and directly does the measure. But we are actually working in the design of this patch to be able to store enough sweat to do a measure, do several measures in time, not just one functional measure. Thank you.
May I make one of my philosophical questions?
Of course.
So you compare your device to a commercial one. So you know that at least it works as well or as bad as the commercial one. How the commercial ones are calibrated and why you didn't follow the same protocol that the commercial one?
So what we did before having this commercial device, we used another laboratory conductimeter called Metrum. So that what we first did was compare the performance of the commercial conductivity, the commercial conductimeter with the laboratory conductimeter that we already had here. So to make sure that that it worked as well as we thought.
Mm-hmm. And that 70% of agreement within this 10% is good enough? Is great?
Yeah, it's great because it allowed us to validate that our conductivity battery sensor that is assembled in a very manual way works as well as a commercial one. So when all the assembly process is made in a more efficient way, we think that the results are gonna also improve.
Mm-hmm. And do you think if you had compared two commercial devices, they will have offered a 100% agreement within each other or not?
Two commercial devices with our conductivity battery sensor.
No, between each other. So.
Between each other.
So it's just to try to compare if your 70% is how good it is, no? If maybe two commercial devices don't agree in 100% of the cases, then this is a good news for you by just having 70% of agreement, no?
Well, like to have the 100% agreement, I think that it's very difficult, although this is a commercial device. But yeah, we think that that getting this 74% was a very positive result for us.
I agree.
Yes, so the problem with this commercial device is that it needs a lot of volume, and 20 milliliters. So to obtain this amount from a volunteer, it's very difficult. And the good part about our conductivity battery is that it only requires 8 liters. And you can obtain the amount of sweat on the intensive exercise, but of course, the more intense exercise you are doing, the faster you're gonna get the volume you need. We know that the sweat conductivity can change depending on the area of the body where you are collecting it. However, since we are mostly looking for differential measures in sweat conductivity, as long as you are collecting the sweat from the same spot, it's not really that important. But probably sweat conductivity in your leg, it's not the same as the sweat conductivity in your back. Ah, vale. Well, we are a little bit far from the wireless communication system because now we are focusing our efforts in what we were talking before, that it's implementing the conductivity sensor in the sweat patch. So now we are focusing on this, but we are also thinking in ways of having wireless communication systems of the patch. But we are also thinking of implementing like a display, implementing a display that that tells the user if this person is dehydrated or not. But it is that this is now we're focusing on this right now, but not so much on the wireless communication system.
Is there any other question? Some people are writing in the chat.
Yeah, we are actually doing additional tests in SAF. We have done 2 tests this week, and we are planning on doing more tests in the future, also with human volunteers, to be able to measure more real sweat samples.
Yeah, as a PI of the research, I would also like to thank you again for all the volunteers. I think it was a very funny episode at CNM. Everybody jumped until they really got the sweat patches full of sweat, and it really helped our research because, as Mark said before, the sample volume is an issue here because all commercial devices available need a lot of volume samples. And it's very difficult. No? So the idea of going from metron, every conductivity we have in the lab that requires a lot of sample, and going to Horrible Aqua, which is a device that is commercial but is not performing so well, and then to go into the battery, we needed really, sweaty patches, and this was really a breakthrough to demonstrate that the battery was in agreement within the 70%. It was a very good. It gave us confidence, and then that's why we jumped into SAF to pursue the research. But it really helped us a lot to go further. So thank again to all the volunteers. Yeah, it's sticking better now.
Sticking plaster to use.
Yeah, the group has acquired a lot of knowledge about different paper absorbance and different, ¿cómo se digo? Esparadrap plasters, different adhesive tapes and biocompatible, of course, adhesive tapes. And so they gather now a good knowledge about how to stick patches in people's arms and backs and whatever you want.